We've been looking at ways to factor polynomials, and in fact, our standard is just use the structure of that polynomial and identify a way to rewrite it. That's what factoring is. We're just rewriting polynomial expressions. Well, today we're going to look at a specific sort of factorization, and when we finish the lesson, we'll be able to factor a trinomial expression. So at the end of the conclusion of this lesson, we'll be able to take a trinomial, a specific kind of trinomial with certain qualities, and factor it. And really, this is probably one of the easier things we'll do. Well, the first thing we're going to always check in the trinomials, we want to find the GCF of that trinomial. If the GCF is 1, we will move on and continue with the factoring process. If not, we'll have to factor out the GCF. And what we're looking at today, we'll work with what we call quadratic trinomials. What makes a trinomial quadratic is it has a power of 2. That's the quality that makes it quadratic. And it's a trinomial, so it'll have 3 terms. Remember, A, we're just talking about with the A part of this, where I write it generically this way. A is just a coefficient of x squared. Whatever number that is in front of x squared that I'm multiplying by x squared, that's my coefficient. So A is just a coefficient, B is just a coefficient, C is just the constant. So that's just the generic form of a quadratic trinomial. We'll start out with an example. Now, as you're viewing this lesson today on video, if you struggle with it or have trouble, let me encourage you to, first of all, write everything down, and secondly, be sure that you stop the video and back it up and make sure you understand what the problem is asking us to do. We're going to start out with example 1, and we're going to factor n squared plus 9n plus 20. Now, looking at this, the GCF here, well, there's not a variable portion of the GCF. The coefficient of n squared, the A portion, is 1, whether we write it there or not. So the greatest common factor here has to be 1. So looking at the trinomial, our first step is to look at the third term, the constant term, this term here. And here's what I notice about that term. I want to write down all the factors of 20. Now, these factors have to give a positive answer. Okay, so if I think about it, factors of 20, numbers that multiply together to be 20 are 1 times 20, 2 times 10, 3 times, no, nothing will give me 20, 4 times 5, and the next would be 5, so I'm done with those factors. Also, I have to remember that negatives will give me a positive 20. In other words, a negative 1 times a negative 20 gives me a positive 20. A negative 2 times a negative 10 will give me a positive 20. And a negative 4 times a negative 5 will give me a positive 20. So I need to keep that in mind. Here's what I want to do. I want to take those sets of factors, and I want to look at which of those pairs, and I'm going to look at the center term. The center term here is 9n. Okay? I'm looking for the pair of factors that when I put them together, add them, or combine them, will give me a positive 9. Okay? And notice I said positive 9. Well, if I put negative 20 and negative 1 together, I get a negative 21, negative 12. So I don't even really need to worry about negative possibilities at all here, because I'm looking for a 2 that will add in the center to be positive 9. So 1 plus 20 is 21. It's not that one. 2 plus 10 is 12. It's not that one. But 4 plus 5 is 9. Aha. That's what I'm looking for. So my factorization then will be this. Now remember, n squared, the only way I can get that is I'm going to take n times n. Cool. Then I know that positive 4 and positive 5, that's the set that I was looking for earlier. And I've used that to factor. So it's n plus 4 times n plus 5. Now I could go through and I could check it. If I multiply those two together, I'll get n squared plus 9n plus 20. Now, if I wanted to double check that, I could just to make sure. I could go through and multiply those. So n times n. Remember, when we multiply it, we use distribution. So n times n is n squared. N times 5 is plus 5n. Okay? 4 times n is plus 4n. And 4 times 5 is plus 20. And I've got to combine my like terms in the middle. So it's n squared plus 20, plus 9n plus 9n plus 20. Okay, so that's what I started out with. So it's factored. This only works for trinomials, that is 3 terms, and it only works when it has a GCF of 1 and that this leading coefficient, the coefficient on n squared, is 1. There are other ways to deal with different trinomials, but for today, we're just looking at a very specific kind of trinomial. Let's look at a second example. We want to factor c squared plus 4c minus 45, negative 45. Let's check our GCF first. Okay, there's a 1 here, so my GCF has to be 1, and there's not a variable with there's a cool. GCF is just 1. I want to write down now the factors of negative 45. Oh, negative 45. Well, that means one factor has to be positive, the other will have to be negative. So I know one set of factors will either be positive 1, negative 45, or the other way, negative 1, positive 45. Now, sometimes with numbers like 45, I might not see all the factors, and there's a way to look at those factors that I can use. Remember, I showed you that you can take your TI-83 and you can put 45 divided by x. Okay, and I want to get this second function, and I want to see the table. So I'll push graph to get to the table. And so I've got my factors here, 1 and 45. Oh, there's one that you might not have seen, 3 and 15. So I'm going to write that down, positive 3, negative 15. Scroll on down again. It's only a factor if there are no decimals. Oh, there's 5 and 9. Cool. I want to write that down. And as I continue to scroll, I have all decimals, so I'll get up to 9. I already got that one with 5 and 9 here. Okay, so that's good to know. So my factors are 1 and negative 45, 3 and negative 15, 5 and negative 9. Or I can move the negative around and say, well, negative 3, positive 15, and negative 5, positive 9. Okay, so now I've written down all my factors. Now we'll look at my center term. My center term here is positive. Now, since my center term is positive, when I go to add these, the larger the two numbers, because remember, if one's positive, one's negative, I have to actually subtract them and keep the sign of the larger number, at least the absolute value of the larger number. So like, I know that negative 45 and positive 1 is negative 44. Well, my center term is actually positive, so I can eliminate all those whose larger numbers are negative. In other words, this first set I can eliminate, but this will probably work because of negative 1, Positive 45 is positive 44. And a negative 3 and positive 15 is positive 12. And I get down here, negative 5 and positive 9. Yep, that is positive 4. Hey, that's what I'm looking for. Remember, I'm looking for that positive 4 right there. All right, so I'm going to take this one. This is the one that works because they combine to be a positive 4. So my factorization then at this point is fairly straightforward. It's just going to be C minus 5 times C plus 9. Because remember, C squared is C times C. So that's good. C minus 5, C plus 9. And that is factored. If I go back and multiply, I'll get the original trinomial. Well, it's not looking so bad after all. Let's look at one more example today before I let you work on your assignment. Example number 3. Here in this example, we want to factor 3y squared minus 15y plus 12. So there's a real possibility this one might have a GCF because a leading coefficient is 3. Well, the only factors of 3 are 1 and 3, so the question is, will the rest of my terms divide by 3? Will 15 divide by 3? Yeah. 15 divided by 3 is 5. Will 12 divide by 3? Yeah. It'll be 4. And notice that I don't have a variable all the way through. So my greatest common factor here is 3. This means I need to factor out that greatest common factor first. I'll pull the 3 out. So 3y squared divided by 3 is y squared. Negative 15y divided by 3 is negative 5y. And 12 divided by 3 is 4. So I'm left with y squared minus 5y plus 4. All right, so now I can go and I can look at just that trinomial and begin to factor it. Now I want to look at, remember the third term. I want to write down all the possible factors of 4. So factors of 4 are 1 and 4. And remember, it's positive 4. And also 2 times 2, which is 4, 3, nothing. So, okay, do my negatives. Negative 1, negative 4, because negative 1 times negative 4 is a positive 4, and a negative 2 times a negative 2. Okay. So looking at my center term is negative. Okay. And I'm going to add these. We'll combine them. 4 plus 1. Well, that's positive 5, and that's positive 4. So I'm looking for a negative 5. So I don't have to worry about that first set. But these will work. And in fact, a negative 1 and a negative 4, that's a negative 5. I'm going to need that one. Negative 2 and negative 2. This is negative 4, but I'm looking for the negative 5. So bingo. I found the factors that will add to be the negative 5 is what I'm needing. All right, so I'm there. I'm in the home stretch. So bring down my GCF. And then my factorization, it's y squared, so it's going to just be y times y. And then it'll be minus 1, minus 4. You know, somebody will probably ask you, hey, does it matter what order these come in? And the answer to that is no. I could have written this way, y minus 4 times y minus 1. And my answer is still the same. Multiplication is commutative. And so that answer is correct as well as that answer. When I multiply that out, all of that out, I'll get the original question I had. So with our standard, that's a way to rewrite this trinomial expression and these will factor these particular type. As long as it's a trinomial, quadratic trinomial, we're able to factor it this way. So those are 3 great examples for you. You have an assignment to work on. If you have any questions, please let me know. And you can factor trinomial expressions.